Myself Smith Patel. I am going to present the overview about FLAC. Now the overview about what is FLAC, codec format of the FLAC, lossless codec comparison. Now the FLAC stands for free lossless audio codec, an audio format similar to MP3 but lossless, meaning that audio is compressed in FLAC without any loss in quality. This is similar to how zip works, except with FLAC you will get much better compression because it is designed specifically for audio. Now the notable features of the FLAC: free, lossless, fast, seekable and streamable. Now what is the meaning of free? Means no cost, no patent, format is fully public. Lossless, the the encoding of audio data incurs no loss of information and the decode audio is bit for bit identical to what went into the encoder. Now the fast, FLAC is asymmetric in favor of decode speed. Decoding requires only integer arithmetic and is much less compute intensive than for most perceptual codecs. Now the another feature is seekable. Seekable means FLAC supports fast sample accurate seeking. Not only that is useful for playback, it makes the FLAC file suitable for use in editing application. Now the streamable. Streamable means each FLAC frame contains enough data to decode that frame. FLAC does not even rely on previous or following frames. FLAC use sync codes and CRC along with the framing. Now the codec format of the FLAC: WAV or AIFF container for raw PCM audio. FLAC using PCM but use the compression to cut the file size between 40 to 60%. Now FLAC format supports up to 8 channels, 4 to 32 bit and all standard sample rate less or equal to 192 kilohertz. Now the architecture of the FLAC codec format. Similar to the audio coder, a FLAC encoder has the following stages: blocking, interchannel decorrelation, prediction, residual coding. Now what is blocking? Blocking means the input is broken up into the many continuous blocks. With FLAC, the blocks may vary in size. The optimal size of the block is usually affected by many factors, including the sample rate, spectral characteristics over time. Now the size used for blocking the audio data has a direct effect on the compression ratio. In order to simplify encoder-decoder design, FLAC impose a minimum block size of 16 samples and a maximum block size of 65535 samples. This range covers the optimal size for all the audio data FLAC support. Now currently the reference encoder uses the fixed block size optimized on the sample rate of the input. Block data is passed to the predictor stage one subblock at a time. Each subblock is independently coded into the subframe and subframe are concatenated into frame. Because each channel is coded separately, it means that one channel of a stereo frame may be encoded as a constant subframe and other an LPC frame. Now the third stage is interchannel decorrelation. In a stereo streams, many times there is an exploitable amount of correlation between the left and right channels. FLAC allows the frame of stereo streams to have a different channel assignment, and an encoder may choose to use the best representation on a frame by frame basis. Now independent, the left and right channels are coded independently. The mid side channels are coded as a mid side, means the left and right channel are transformed into mid and side channel. The mid channel is the midpoint of the left and right signal and side is the different signal. Third one is channels are coded as a left side. The left channel and side channel are coded. In the right side, the right channel and side channel are coded. Now the prediction. Last stage. FLAC uses 4 methods for modeling the input signal. First is verbatim. This is essentially a zero order predictor of the signal. the predicted signal is 0, meaning the residual is the signal itself and the compression is 0. Now the another is constant. This predictor is used whenever the subblock is pure digital silence. For example, constant value throughput, constant value throughout. The signal is run length encode and added to the stream. Another is fixed linear predictor. FLAC uses a class of computationally efficient fixed linear predictor. FLAC adds a fourth order predictor to the 0 to third order predictor used by shorthand. Next is a FIR linear prediction. For more accurate modeling, FLAC support up to 32 order FIR linear prediction. The reference encoder uses the Levinson-Durbin method for calculating the LPC coefficient from the autocorrelation coefficient, and the coefficient are quantized before computing the residual. The FLAC reference encoder estimates the optimal precision to use based on the block size and dynamic range of the original signal. And the last one is residual coding. FLAC currently defines two similar methods for coding of the error signal from the prediction stage. The error signal is coded using rise codes in one of the two ways. Now one is the encoder estimates the signal rise parameter based on the variance of the residual and rise codes the entire residual using this parameter. Now the comparison. FLAC and WavePack are only lossless compression codec that are based on the open source, available via no license cost, means free, is streamable and seekable. Now this is the comparison graph that is available on the net, and this is the reference. So thank you for listening.